Good. Okay. So good evening, everybody. Welcome to Monday night's class for Math 116. And I hope everybody's doing okay. Let's see, don't forget to sign into the chat. Please, when you sign into the chat, use a first name and a last name. That helps me match it up with my listing from the school. Some announcements. First, we have, let's see. When's the next we got going here on the schedule? So this Friday is the last day to add or drop any the deadline to add or drop without getting a W in the course, and the last day to get a refund. So that's this Friday. If you want to get your money back, or you just want to drop and you don't want to get a W in the course. A W is a withdrawal code in lieu of a letter grade. So you can only get so many withdrawal codes, and then the administration gets upset about that, and they could put you in academic probation. So nobody wants that. That's a pain. Okay, then let's see. The following Friday the 18th is actually a holiday in the San Diego Community College District for Lincoln's birthday. And then the following Monday, the 21st, is also a holiday. So that's what we're looking forward to here. And let's see, 1, 2, 3, 4. And actually, week number 4, we're supposed to be back into the classroom. So I'm hoping that happens. I do have a scheduled for a test that Monday and that Wednesday, and I'm thinking I might move that a day, just move the whole test schedule up a day, because of the way that they currently have everybody getting back into the on campus due with COVID. It's kind of awkward, and it's causing everybody difficulties. Let's see. So another announcement. So they're looking for what are called peer navigators. So peer navigators are positions that start in the summer, but they could go on through the whole academic year and pay up to $15 an hour. Well, $15 per hour, up to 20 hours per week. Okay, and they have a bunch of duties. Let's see. You're eligible to be a peer navigator if you're a full-time student, and you enroll and complete at least 12 units each semester. Okay. And you need a 2.75 GPA or higher. Let's see. And you got to be available during the summertime. Okay. I don't know if anybody got these announcements. Did you get an announcement on the peer navigators through your school email? Anybody? No. All right. Well, what I'll do is I'll forward these to you. And then on the let's see, what day is this? They're going to have a Zoom meeting to explain everything about the whole peer navigator system. And I can't exactly see when that is on the flyer, but it looks like it's supposed to be, that's, let's see, I think it's Thursday. Yeah, Thursday, February 17th. But I'll send you that flyer also. So I'll copy those and send them out. Okay, let's see. Anything else about things that are happening? All right. Then what we'll do is take a look at what we covered last week on the board behind me right here. So let me move my seat here. Okay, let's see. We'll start out on this end over here. So we covered section 5.1 up there. Let me get my head in the zone right here. Let's see. 5.1 on quadratic functions. We talked about the two forms of the quadratic function. So there's the general form, which is y equals ax squared plus bx plus c, which we're used to working with up to this time. And now we have another form called the standard form, which is y equals a times the quantity x minus h quantity squared plus x, or plus k, excuse me, not x. The x is inside the parentheses there. So in terms of the general form, f of x is equal to ax squared plus bx plus c. Remember, you can write f of x or you can write y, because y is equal to f of x. That was the general, one of the general concepts of the whole function idea, that y, the output variable, is equal to a function of x, the input variable. So if it's in this form here, f of x is equal to ax squared plus bx plus c, the general form, then the a term, whatever term is attached to the x squared, the squared variable. Okay, if a is positive, that tells you that this parabola opens up. If a is negative, then it opens down. Okay, and we're going to see that's the same for either form. The vertex. So the vertex is equal to the x value of the vertex is minus b over 2a. So you write down the a, the b, and the c. So minus b over 2a, that'll give you the x value. Then you substitute that value back into the general form of the equation, ax squared plus bx plus c, and you can solve for y. So y is equal to a function of minus b over 2a. That's what's written up there. And then we talk about the intercepts. Remember, the intercepts is where it crosses the axes. So the y-axis intercept is where x is equal to 0. So that's going to be the c term, whatever term there is that doesn't have an x on it. If there's no other number here that doesn't have an x on it, then the y-axis intercept is 0. It's the origin. For the x, then we got to solve this quadratic equation, and we can use the quadratic formula or factoring for that. So I just wrote down the quadratic formula there. Okay. Let's look at the other half of the board here. In the standard form then, starting on the other half of the board, the standard form, I didn't write it up there, but that's a times the quantity x minus h quantity squared plus k. So the opening, the same thing of a applies. So whatever number is in front of the binomial x minus h, if that's positive, then it opens up. If that's negative, then it opens down. If there's no number there, then the number is 1, is plus 1 if nothing is there. Vertex. So the vertex then is the ordered pair HK. So notice HK is in the parentheses. So H is in the parentheses. K is the number at the end outside of the parentheses. And the one trick on that, it's going to be the opposite sign. So if there's a plus 3 inside the parentheses, then the H value for the vertex is negative 3. If there's a negative 3 inside the parentheses, then the X value for the vertex is positive 3. It's the opposite sign. That's the only tricky bit about this standard form. But the vertex values are right there. You just got to remember that little sign thing that you have to deal with. Okay, for the intercepts in the standard form, then the y-intercept, x is equal to 0. So I just simplify it. And I can't use this number here. That necessarily isn't the y-axis intercept. I have to simplify this whole thing and squaring it. And there's a number in front. So I got to multiply by that to get rid of the parentheses. So I have to do all of that. And then put x equal to 0, x equal to 0 before I simplify it, and then simplify it. The x-axis intercept then is y equals 0 at the x-axis. So I simply solve it for x. So that means I would multiply this all out. I'd get a quadratic equation in general form, and then I can use factoring or the quadratic formula to solve that for the x-axis intercepts. Remember, those x-axis intercepts are also called the roots of the equation or the zeros of the equation. So we use those terms all synonymously for the x-axis intercept, not the y-axis, That y-axis intercept is just the y-axis intercept, but the x-axis intercept are called roots or zeros of the equation. And we're going to talk more about those as we go into further chapters here. To change the forms, to go from the standard form to the general form, you simply remove the parentheses and combine like terms. So how do we remove the parentheses? Well, we got to square this binomial right here. And then once we do that, we can combine like terms and get the general form. Remember, we always write it in what's called descending exponent order form. So you put the x squared term first, the x to the first power second, and then the number without the x on it last. So that's called descending exponent order form. To go from general to standard, though, isn't quite as easy. To go from general to standard, we have to use the completing the square technique, which we can look at again today. Okay, so any questions on this half, on this side right here? All right, so let's look at the other side. Okay, so the method to graph. So in order to graph a quadratic equation, you have to know where it starts at. So it starts at the vertex. So you find and plot the vertex. Then you draw the symmetry axis, the axis of symmetry. Remember, a parabola is the same on the left as on the right. So if I just find some points on one side of the curve, say the right-hand side of the curve, then those corresponding points are also on the left-hand side of the curve. I just have to go across the axis of symmetry. And so the axis of symmetry goes from the vertex, it goes up if A is positive, it goes down if A is negative. Then I'm gonna make an XY table, pick two X values, find two corresponding Y values, plot the point, sketch the curve. So you need at least 5 points. So you already have 1 point if you have the vertex. Then you just need to pick 2 other points on one side of the curve, on one side of the axis of symmetry. Pick whatever is the easiest. So use like x equals 1, x equals 0, 2, something like that. So real simple values, and then you'll be able to get a nice value for y, and you'll have 5 points. And then you can sketch a reasonable curve. Remember one thing, when you sketch it, a parabola isn't pointed, a parabola is round. So if you remember last time I brought in a parabolic dish antenna, and you could see it's actually round like a circle at the bottom. Okay, it's not a circle, but it looks like a circle. If I didn't tell you that was a parabolic dish antenna, you might think that that was actually a circular antenna. All right. So we can actually find the equation of the function from the curve. So if I have a graph of the curve, I can find the equation of the function from that graph. And the way I do that is I pick the HK value. So I try and pick the vertex value right off the graph. So that's the lowest point or highest point on the curve. And then I put it into standard form. I put it in the standard form, the HK in there. Remember, I have to put the opposite sign for the H in there. And then I'm going to pick another XY point. So I pick another XY point on the curve, any easy point on the curve. And what I do with that is I substitute it back into where the X and the Y are in the standard form. Now I only have one variable left, and that's A. So then I can solve that for A. Just simplify it, get rid of the parentheses and square it, parentheses, and then solve for A. All right. And then once I get the A, then I can write it in a function. I can write the function equation in standard form with the A, the H, and the K. Okay, so that's just a quick review of what we covered next time, or covered last time, excuse me. Let me go back over to this side. All right. So any questions on homework, for example? Remember, we aren't going to turn in homework on Canvas. We're going to turn it in hard copy when we come back into the classroom in week 4. Okay, so you just turn it in there. And I'll give everybody extra time because this whole semester is so messed up. I'll make sure everybody has plenty of time to get up to date on the homework. Yes, go ahead.
Sorry, excuse me. Could you possibly go over number 13?
Okay, in which section? 8.1 or 8.2?
Oh shoot, it was homework 2, 5.1.
Okay.
I don't know. I don't know what section that would be.
Number 13 would be in 5.1, excuse me. Sorry, I didn't mean 8.1 or 8.2.
Oh.
That's my 96 course, which is later on. So unfortunately, we crossed wires right there. That's my fault. So 5.1, number 13. Yeah, we're going to work that.
Yes.
So another thing on the homework. So do each assignment separately. So like assignment 2 has problems from 5.1 in it. Yeah, let me get back to the homework here. Yeah. So do assignment 1 separately and then do assignment 2 separately. Don't mix them up. I know both of the assignments are in section 5.1, but don't mix the problems all up. That just makes it really hard for me to grade, especially if we do it in week 4 and I have a lot of people turning homework in and I need to get it graded for your test grade. So I want to make sure that I'm able to grade it as expeditiously and easily as possible. So if you do each assignment on one paper or 2, whatever it takes you, but keep the assignment separate. That's what I mean. Does that make sense?
Sir.
Any questions on that? Yeah, Fernando, what's your question?
Will the homework be graded kind of like on accuracy or completion?
Homework is graded on completion.
Oh, okay.
Okay. So seriously, I'd like you to get the right answer, but if you can't, that's okay too, as long as I can see that you're working on it. That's what I'm concerned with. So I don't want to see just a list of answers out of the back of the book. What I want to see is the work. So that's what I want to see. Okay.
And when we are in person, will we go over the homework?
I'm sorry, say again.
When we are in person, are we going to go over the homework together? Or is it
we'll answer questions on the homework just like we're doing now.
Okay.
Okay. So I'm not going to spend a whole class just on going over homework. I'll return your homework to you, the graded homework I return back to you, then that goes into your notebook. Okay.
Also, I had a question apart from number 13. Your office hours are from 4 o'clock to when, but they're not on Zoom, correct? They're in person. I was just
No, they're on Zoom. We can't do the office hours in person because we're not on campus.
That's what I thought, but
yeah,
I tried to go into the Zoom and this morning, or not this morning, at around 4 o'clock, and nothing would come up. So it's just
okay. Well, keep in mind that that Zoom period was last Thursday.
Oh my gosh.
So I'm only going to do the Zoom once a week. Okay.
Oh, your office hours? Okay.
Yeah. So I sent that email out separately. Well, I notified you on the when we sent out the homework and on for the 2nd. So when we sent that out, then I said we're going to hold a Zoom on Thursday from 4 to 4:50.
Okay, that makes a lot more sense. Yeah. Thank you.
So we'll do one this week too. Now, whether it'll be on Thursday or Friday, I'm not exactly sure. It depends on my schedule for my other job.
So if we can't make it on Thursday, are we able to try and do a different time? Because I work Thursday nights, so it doesn't work for me to do it on Thursday evenings.
Okay. Is Friday better? Well, it's not in the evening either. It's in the afternoon, but that might conflict with your job also.
Yeah, I work the weekends and then do school like at the beginning of the week. So like Thursday, Friday evenings are not good for me.
Okay. Well, I don't know what to do with that. So I just have to do it at whatever time I can get free and that most people can attend. So that's the way we're going to work office hours. Now, if you have questions on particular homework problems, you can always email me separately.
Okay.
And then we can work something out there too.
Okay. Sounds good. Thank you.
Okay, good. So let's go back to this homework number 13. Whoops, sorry, baby. Sorry, puppy. I kicked my
I'm
dogs.
sorry, Professor. I have a quick question.
Yeah.
So I just joined the class yesterday, so I was just wondering where to find the course materials and stuff.
Where to find the course materials?
Yes, like the book, etc.
Okay, well, I sent you a copy of the syllabus. So the book is listed on the syllabus.
Okay, got it.
And the easiest place to get it is go to the OpenStax website. Just put in OpenStax I think it's .com. We had it in the handout last time. Let me see. You can go to I know we might have some new people coming in tonight. So, oh, it's openstax.org.
Okay,
It's
cool.
OPENSTAX.org.
Awesome, thanks.
I'll write it on the board right here. And if you go there, you'll find links to their various textbooks and that, and you can actually download a digital copy from that site. You can also get a hard copy at the bookstore. You can rent it through the bookstore, or you can probably rent the same book through other options on the internet.
Perfect.
Okay, let's go and see this problem right here, number 13. Okay, so 13 is said for the wait a minute. For the following exercises, rewrite quadratic functions in standard form and give the vertices. Okay, so 13, that's 3x squared minus 5x minus 1. Okay, so the first thing, let me clean up the board and then we'll work that one. Okay. Let's see. Eraser. Okay, so here we're going to change the form of the equation. So let's see, it's f of x is equal to 3x squared minus 5x minus 1. Okay. So the first thing I'll just say, I'll just use y over here. And what I'm going to do is separate the x terms. So I'll have y is equal to 3x squared minus 5x. And then I'm going to go plus something else right here, minus 1 plus something else right here. Okay. So the first thing I got to do, though, is I got to factor out this 3. So the x squared term coefficient has to be plus 1. So I have to factor out the 3. So even before I put those lines on there, I should do that. So I get y is equal to 3, then times the quantity. So over here, I'm going to have x squared minus 5 thirds x plus something. Okay. And then we get -1 plus 3 times that's something over here, whatever it is. Okay. So what I put in here is 1/2 of the middle number squared. So I'm going to put in this 1/2. Hang on just a minute. I'm going to get some more room here. I'm running out of room. I'll write that last part in there again. So I'm going to go plus 1/2 of 5/3 quantity squared. It's a 5 right there. So 1/2 of 5/3 quantity squared. And then that closes this parentheses right here. Then I go -1 plus, and then I'm going to go 3 times 1/2 of 5/3 quantity squared. So whatever I put in on this side, and I put the 3 there because I have the 3 out here in front. So I have to put it over there also. Okay, does that make sense? So I have to put that over there, and then the 1/2 of 5/3 quantity squared. Okay, so what I'll get then is I'll have y is equal to 3 times x minus 5/3 x plus, excuse me, and on this side here, what I have is, I got nested parentheses right here. I got 5/6 squared. But I'm not going to square it. I'm just going to leave it like that, 5/6. Okay, on this end, I'll square it. -1 plus 3 times, and now I got 5/6 quantity squared. So that's going to be 25/36. And I have the 3 out there in front. Okay. So this one is a little bit more detailed because of the fractions involved. All right. So right here, then I got y is equal to 3 times. Now I can write this as a binomial squared. So if this middle term here is negative, then I'm going to have x minus, so it's going to be negative down here too. And then what I put in here is just that number right there, 5/6 squared. Okay. Then on the outside over
Where
here.
does the
now
5/3 go?
Say what?
Where
I'm
does
sorry,
the
say
5/3
what?
go?
Where'd the what go?
Like 5/3. Where does that number
Oh.
go?
The 5/3 is inside this number right here. See, it's right there. So I put in 1/2 of 5/3 quantity squared. Well, 1/2 times 5/3 is 5/6. So the 5/3 is inside this number right here.
But like, where does like, so it says 5/3x. So does that like x just disappear?
No, that remember, this is a binomial. That should be a squared right there. This is a binomial that I'm squaring. So if I square this binomial here, I'll actually get this right here. X squared minus 5/3 x plus 25/36. If I were to square this binomial. Okay, I know it might not seem that way, but it will. I put this one in there because it has fractions in it, just so you would have an opportunity to try and work one with fractions. Now, on this last term over here, so notice 3 goes into 36 12 times, so I have 5/12. So now this is -1. So 1 you can make into any fraction that you want of a number divided by itself. So what I want is a fraction of 12s. Okay, so what I'm going to get is plus a -12 plus 25. Maybe hang on. I'm getting ahead of myself and I'm probably confusing people. Okay, so let me back up one. So I'm going to change that one into -12/12, like that. Okay, that's the 1 right there. Then I'll have plus 25/12. So 3 times 3 into 36 goes 12 times. Okay. So you can see this is going to be minus 13, or excuse me, plus 13/12. So then my final result then, let me write down the final result here. So y is equal to 3 times the quantity x minus 5/6 quantity squared plus 13/12. And I'll put a box around it. Okay, so that's what it looks like right there. So on the test, okay, for testing purposes, I'll just give you one with whole numbers. It's not going to have weirdo fractions like that in it. So it'll be one with whole numbers. I just gave you this one with fractions, so you'd have an opportunity, quote unquote, to work one with fractions in them. Okay. But does everybody see, understand the completing the square process? Because that's what we're doing right here.
Oh, sorry, you can go.
Yeah, go ahead.
So like 2 lines up where it says 3x squared minus 5/3 x plus 5/6 quantity squared.
Yes.
I'm wondering how the 5/3 went away and the next one down.
Okay. The 5/3 didn't go away. It's inside of that number. So we put in the way you do this completing the square, you always 100% of the time put in a 1/2 of the middle number quantity squared. The thing is, I didn't square it right here because I just wrote 5/6 quantity squared because I'm going to put 5/6 in right here. Okay. I only squared it on the other end. So that 5/3 is actually inside this. 1/2 of 5/3 is 5/6. Okay. Don't think about it too hard. What I want you to do is just understand the process.
Okay, the reason I asked about number 13 was because when I was doing it, I got stuck with the putting the 3 into the 5. So you're saying whenever it would result in a fraction to just kind of keep it, like not convert it to a different number? Like that's what threw me off, was keeping it as a
Okay,
fraction.
well, another thing, when we do this completing the square process, it's important that the coefficient of the squared term right here has to be +1. So that's why up at this step right here, I actually factor out a 3. So when I factored out a 3, notice 3 times x squared is 3x squared. 3 times negative 5/3 x is negative 5x. Okay, so I factored out a 3. And that made this coefficient right here +1. And when it's +1, then I can do the completing the square process. But you can see what that results in is an a term right here in front of the binomial squared. So this is a times the quantity x minus h quantity squared plus 13/12.
And would it always be 1/2 times your fraction, or would it just be it in this case?
No, it's always 1/2. You
Okay.
do 1/2 of the middle number quantity squared 100% of the time. That's what you do. Okay. Now,
Okay,
for
thank you.
testing purposes, I'll just give you, I want you to do one on the test, but it'll involve simple whole numbers. So it's not going to be like funky fractions like this. Okay,
Professor,
good.
may I ask a
I
question?
know you keep
Yes. Someone asked another question. Was that you, Anna?
Yes, sorry. I just added your class, so I wasn't here for lecture last week, so I apologize if you already said this, but when I was going through the book trying to look at this section, and for the test purposes, do you want us to only use the completing the square method, or is it also okay to use the finding like the vertex and then plugging that back into put it into standard form?
Okay, well, there's the reason you want to do the completing the square is to change forms from general form to standard form. Now I can find the vertex and graph the function in either form. Okay, but I want you to do that completing the square process. And you're gonna use that completing the square process again if you go on into pre-calculus, trigonometry, and pre-calculus. They do the completing the square process in those two curriculum.
Okay, thank you.
Yeah. Okay. All right. I don't want you to get too wrapped around the axle about it. I just want you to understand the basic concept of completing the square, how we're doing it, and be able to graph the function from either form, the general form or the standard form. If I give you one form or another form, you can graph the function from that form. Okay, good. I know. It's not easy when those fractions are in there. Okay, hang on just a minute. Okay, let's see. Put this back over here. Wait a minute. My studio space is so small that things start falling on the floor if I'm not too careful. So I have to be careful about what I'm doing. Okay. So what I'm going to do is get back over here to my book and my notes. Put my main book, my notebook back over here. Remember, one of the things that I'll be looking for on test day, whenever we do it, is your notebook, but it'll be back in the classroom. Okay, so you need to make some sort of a notebook. A 3-ring binder is best. Again, if you want to keep extra other classes in there at the same time, that's fine. Okay, so what we're going to do is pick it up on where we. Oh, good. So we're picking it up on page 349. Objective number 3, to find the domain and range of a quadratic function. Okay, so let me go back over to the other side here. Much. Okay. So now we're going to talk about the concept of domain and range. Hang on, let me get my notes back over here. Here we go. Okay. So people get the domain and range always mixed up. So the domain is the set of X values that function is good for, and the range is the set of corresponding Y values that function is good for. But the way you can remember it is this. Remember that we write an ordered pair, an XY ordered pair in alphabetical order, XY, okay? So we go X, Y for our ordered pair is equal to domain and range, like that. So the domain, the D is domain that corresponds to the X values, the input value, and Y is the range that corresponds to the output value, the Y value, the output value. So remember, this is in, out, domain and range, X, Y, etc. Okay. So I'll write that up there too. So this is the in and the out. Okay. Input, output. And the domain and the range. Okay, good. So typically for parabolas that we're looking at, the domain is real easy. So I'll write it in interval notation. So the domain is the set of negative infinity to positive infinity. So that's it in interval notation. In other words, it's the set of all real numbers. So another way you can write it is like this. If you write an uppercase R with a double leg on it like that, that is a symbology for the set of all real numbers. I'll write that down here too. All real. Okay, hang on just a minute. Okay, so all real numbers is this sort of weird uppercase R. So it's weird because it has a double vertical leg right there. Okay, but that means the set of all real numbers. Or in interval notation, it's like this, parenthesis, negative infinity, comma, positive infinity, close parentheses. So that's the domain in all real numbers. The thing that isn't all real numbers is the range. That's the set of corresponding Y values. So notice if I have let me just write a general coordinate system over here, X, Y. So if I have a parabola in there like this, then notice that parabola, that if I go up far enough, that keeps going out this way, further and further and further. And if I take it up to infinity, it actually goes up to infinity in that direction and that direction out there to the right. And this goes up to infinity, up like that, and then that direction out there to the left. So that's the X values. There's my X's and my Y. But my Y value, notice my Y value starts right here. There's the vertex point right there, HK. And that's where, oh, my head's in the way. And that's where my Y value starts. And then if it opens up like this, then it goes, then the range goes up this way right here. So in this particular case, the range is equal to, it starts here at K. And that should be like this. It should be a bracket like that because the range point is included. So that's H, comma, positive infinity, parenthesis. So that's it in interval notation. Remember, infinity, I don't know that value, so that's always a parenthesis. But here at the vertex, I do know that value. That's the value of not H, but K. That's the value of K. So remember, it's HK, XY. Okay, so it's K up to positive infinity. So in this particular case, A is positive. If A was negative, then it would go down. Okay, so let me make that note over here on the other side for range. So the range is dependent. The range is dependent on two things. One, the K value, where does it start at, and whether A is positive or negative. Okay, so let me see how I'm going to do that. Okay, so we'll go like this. So if A is positive, then the range is going to go like this. So it's going to start at K. Ah, dang it. Once again, the K is included. So it'll be a bracket, K, comma, positive, infinity, parenthesis. Okay, so once again, infinity is always parenthesis. If A is negative, so if A is negative, then once again, it still starts at K, but now it goes in the negative direction, so minus infinity, close parenthesis. Okay. So the range will the domain again is negative infinity, positive infinity, but the range depends on where the vertex point is and then whether the A is positive or negative, which tells me if it opens up or opens down. So if A is positive, it opens up, so it's going to go up to positive infinity. If A is negative, it opens down, so it's going to go down to negative infinity. Okay, does that make sense? So that's the domain and the range. All right, let's see. Now we're going to talk about, so that's pretty straightforward. Let's see if there's any examples in there. Let's see. Oh, so let's look at example 4. So there is an example in there. So this is example 4 to find the domain and range. Okay, cool. All right. Go up here. Okay, so we want to find the domain and range for, and let me write it down here. So now I'm in example 4 on page 350. It says f of x is equal to negative 5x squared plus 9x minus 1. That's a squared right there. Here we go. Minus 1. Okay, so this is in general form. So I know, so what I need to know is where it starts at. So the first thing I got to do is find the x value anyway. So I find the vertex. So x is equal to negative b, so minus 9 all over 2a times 2 times negative 5. So that's equal to negative 5, that's right. So that's equal to positive 9 over 10, or 0.9. So it's a positive 9/10. That's the x value. Then y is going to be f of 0.9. Let's see. Yeah, I'll put it in that form. Okay, so that's going to be minus 5 times 0.9 quantity squared plus 9 times 0.9. Oops. And then minus 1. Okay, So y comes out to be, and I will look in the book to see what this is. So y comes out to be 3.05. Okay, and that's the important one. This is the one that I need to know right here. But I got to find x first if it's in this general form in order to do that. So now that I got that, then I can find the domain and range. So the domain, I'll just use uppercase D for domain, is going to be equal to negative infinity to positive infinity. That was easy. The range, I'll use uppercase R to indicate the range. That's going to notice that A is negative, so that means it opens downward. So right over here, I make a note that A is equal to -5, which tells me that it opens in that direction, down like that. So the range is going to start at 3.05. And notice that's in brackets because that point is included, comma, negative infinity, parenthesis. So there's my domain and range right there. Okay. So once again, I need the two important things I need to know for the domain is no problem. That's minus infinity to positive infinity. The problem is range. So the two important things I need to know there are the A term. Does it open up? Does it open down? And then I need to know the Y value of the vertex. Okay. If it's in standard form, the Y value of the vertex is given to me. If it's in general form, then I have to calculate the Y value of the vertex. In order to do that, I need to find the X value first. All right. Does that make sense for domain and range?
So is the domain always negative infinity and positive infinity?
For our purposes, for a parabola, yes. Yes, that is correct.
Okay.
Now, in a real life problem, you might not care about things in the negative X direction. So it all depends on the situation. It's situational. But for mathematical purposes, for our purposes of graphing and calculating the domain and range for mathematical, just pure mathematical problems, then it's always negative infinity to positive infinity. Okay. All right. So what do we got next here? Let's see. Hang on. I got to move around. Okay. All right. So we did a domain and range. So next we are going to, let's do another one with domain and range. So this is try it number 3. So on all of the, not all of them, but most of the examples, the author will have another one that you can do on your own, which is called the try it example. So this is actually, it follows example number 4, but it's try it number 3. But the reason I picked that is because it's written in standard form. So let's take a look at that. Man, let me go over to the other side here. Okay. Come here. There we go. Down. Okay, good. Let me clean up this side. Okay. So this is called try it number 3 on page 350. So find the domain and range for, let me write it down here. So we got f of x. F of x is equal to And then it's 2 times the quantity x minus 4/7 quantity squared plus 8/11. Okay, so this is written in standard form, which means that the vertex is given to me. And the only thing I'm concerned with for the domain and range is the y value of the vertex, which is this point right here. So this is my concern right here. That is K. And that's the y value. Also, I notice right here, A is positive, which means it opens up and up like that. Okay, can you see that okay? Let me go back over to this side. Okay, so it opens up and up like that. So right away, I can write the domain. I'll just use uppercase D for domain is equal to -infinity to +infinity. All right, that's easy enough. The range then is equal to, so it's going to start right there. So I got bracket 8/11, comma, and it opens up. So positive infinity parenthesis. Okay, so there's my domain and there's my range. And it's easy enough. So if it's given to in standard form, it's a piece of cake. Real easy. I just got to pull the numbers right off the standard form. Where it isn't is if it's in general form, because then I got to do some calculation. I got to do some arithmetic if it's in general form. Okay. So any questions about domain and range?
Professor?
All right, good. Then let's move
Professor?
on. Yes, question.
And sorry, I just want to clarify for so I understand. So the infinity sign in there is just saying that it starts at like 8/11 and it's just anything greater than that is included. That's what that means, right?
Correct. This is
Okay.
called interval notation. And you can check this out in the appendix in the back of the book. Interval notation. So in interval notation, it looks like an ordered pair, but it's not. Okay, it's a range. And so this is the starting value right here. And it uses a bracket if that starting value is included. So here the starting value is included because it's the y value of the vertex and comma the ending value. So here the infinity then is always a parenthesis. Parenthesis means it's not included in the solution set. And nobody knows the value for infinity. So that's why infinity is always a parenthesis.
Yeah, I think I was getting confused because I was reading it like an ordered pair. So that makes sense. Thank you.
Yeah, it's not an ordered pair. It looks like an ordered pair, but it's not. It's a range of values. So here range means several things. So this is a range of values too, from -infinity to +infinity, which means that any real number is in that domain. Okay. All right, good. So now we're going to move on to objective 4, determining the maximum and minimum values of a quadratic function. Okay, good. Yeah, right. Let me go back over. So any other questions on this one? Everybody clear on that? How about this one over here? Everybody's clear on that. Okay. Let me go back over to this side. I want to clean up this side and start working here. So this is objective 4. the maximum or minimum function value. And this is on page 350. Objective 4, okay? All right. So the maximum or minimum value is going to be represented at the vertex, okay? So let's see. So maximum the vertex is going to go like this. And at some point, it's going to max out right there. Okay, so for the maximum, A is negative. Okay, so that means there's a maximum value. Now, the function value is going to be whatever y is at that point. Let me be more specific. In fact, let me rewrite this one right here a little bit. I'm not satisfied with that. Okay, so I wrote down the max or min function value is the y value at the vertex. Okay, so that hopefully that clarifies it a little bit. So y is going to, remember the function f of x is y. So the function value is y at the vertex. X is the input value, y is the output value of the function. So for a maximum, A is negative, and it goes like this. So whatever the y value is there at the vertex. For a minimum, A is positive, and it goes like this. And again, there's the y value at the vertex. Okay, so remember, y is a function of x. So that's going to be the function value at the vertex. And we're going to see how this plays out, especially in word problems. We're going to be working some word problems that deal with this. Let's look at it, see if there's an example here in the book. So the author, in fact, the author has a word problem dealing with that. Ooh, excellent. Okay, so let's take a look at that. So this is example 5 on page 350. Actually, page 351. Okay, so let's take a look at this and see what it says. So it says, I'm going to read it here. Like turn around like this, get my book over here so I can read it. Read it to everybody. Whoops, hang on. Hit my pen, my table. Okay, so it says a backyard farmer wants to enclose a rectangular space for a new garden within her fenced backyard. She has purchased 80 feet of fence, of wire fencing to enclose 3 sides with and she will use a section of the backyard fence for the 4th side. Okay, so A, find a formula for the area enclosed by the fence on the side of fencing, perpendicular to the existing fence, have length L. Okay, well, I'll draw a picture of this here in a minute. And then B, what dimensions should she make the garden to maximize the enclosed area? So we want to maximize area. So there's that, the key word is maximize. Okay, so the first thing is I got to find a formula. So it looks like this. Okay, hang on, she got how many feet of fence? Where's the fence? Where's the fence? Where's the fence? I think it's 80 feet, right? She purchased, oh, there it is, 80 feet. I couldn't see it. So it's 80 feet. Okay, so basically we have this. So we have, here's the fence. And then here's the garden. So the garden has a length and it has a width and a width over here. Okay. Now the perimeter of her garden, the fence, let me use these words here. I don't like it because she used they used the word fence in there twice. So let's do this. So the garden is up against the house. Okay. So the fence is 80 feet. So the perimeter right here, P is equal to 80 feet. Okay. So we got to find 2 things. One, A, find a formula. And B, maximize area. Okay, so those are the 2 things we need to do. So the first thing is we got to find this is going to result in a quadratic formula, a quadratic equation. Okay, so this is a rectangle. So the shape is a rectangle. So the relationships that I know for a rectangle are perimeter and area. So the perimeter, P, is equal to, in this case right here, the perimeter is 2W plus L, or L plus 2W. Normally, the perimeter of a rectangle is 2L plus 2W, but here I'm only using the fence on one of the long sides. The other side is up against the house. Okay, does that make sense? So then my perimeter relationship is L plus W. And then I know the area, A, is equal to length times width. So those are the 2 relationships I know for a rectangle. Okay. So we're going to start with the perimeter. So I know that, let's see, L plus 2W is equal to 80. Okay. And notice then I can solve this easily for L. So L is equal to 80 minus 2W. Okay. Then I can substitute that into the area equation. So A is equal to length times width is equal, but length I have right here. So that's going to be 80 minus 2W times W. So there, this is L. I substituted for L right there. Now I got area as a function of width is equal to minus 2W squared plus 80W. That should be 80. Okay, 80W. Okay, so there's part A. My formula is right there. Okay, so does everybody see how I got that? So I used relationships that I already know for a rectangular shape, the perimeter and the area. All right. And from that, then combining those two, I actually got a quadratic equation, which is the equation of a parabola. Okay. Now this is A. So this is A right here, my formula. Okay. So I answered that part right there. Okay. This part here. There's my quadratic equation. Okay. Let me go over to this side here. So I'm going to erase this side here so I can continue the rest of the problem on this same board right here. Okay. Yeah, let me move this around that way a little bit. Need some more room right here. Okay, so I'm going to write it again up here. So I got area as a function of width is equal to minus 2W squared plus 80W. Okay, so notice this is like f of x. Okay, so this is analogous to f of x is equal to ax squared plus bx plus c. Okay, so it's written in general form. So here my a is -2, my b is 80, and my c is 0. Okay. Now I need to maximize the area. So I need to find the vertex. Okay, notice in this problem, A is equal to -2. So that means it opens like this. So the vertex point is going to be up at the top right there. Okay, and that would be the maximum function value. So once again, I got to find x right here. So x is going to be, not x, but w, excuse me. There we go. Put this one over here. We got another eraser here that I can move over here. Okay, good. So W is equal to minus B over 2A. So that's equal to minus 80 over 2 times A, which is -2. Okay. So that's going to be 80 divided by 4, which is 20. And notice that's 20 feet. So that gives me one of the dimensions. So 20 feet is the width dimension right there. Ah, excellent. Now I got to find the y value too. So this gives me W. So notice the y value then is going to be the length. So this will give me the dimensions that'll maximize the area. So L is equal to A of 20. So that's equal to, where's it? Oh, minus 2 times 20 squared plus 80 times 20. Okay. Oh, what this gives me then is the area. Excuse me. Let me back up one. It doesn't give me the length. It gives me the area. My slight error right there. Let me back up right here. So then the maximum area is going to be minus 2 times 20 squared plus 80 times 20. Okay, so my maximum area then is going to be what? Let me see. Here's my calculator. It's been a while since I've done this problem. That's not the right one. Right. Hang on. Oh, there it is over there. Yeah, I was looking for my favorite calculator. That's this one. Okay, so we have turn it on, clear out everything, on, clear. So now notice whenever you do this in the calculator, don't use the minus sign for -2. You got to use the change sign. Minus means subtraction. So here I'm going to go change sign, boom, and then I'll put in 2 times, and then I put in 20 squared. So I'm going to put in 20, and then I'm going to hit x squared. So that squares the 20, okay? Plus 80 times 20 equals, and I got, wait a minute. Oh, I made an error. Notice I got a negative result. So I go back and I look at my work. It shows me right there, and I can see, oh, I used 8 instead of 80. What a bonehead I am. So I'm going to back up one more time, clear that out. So I'll go change sign 2 times 20x squared. So all scientific calculators will have a squaring key, and that's what I use. Then plus 80 this time. Good, 80 times 20 equals, good, and I got 800 square feet. Where'd my other pen go? Here we go. Good. So I got 800 square feet. So that's the area, the maximum area. So then L is equal to 800 divided by 20. So L is equal to 40 feet. So I got the formula, and then using the formula, I was able to find the Y value of the vertex. So this is the Y value of the vertex. That's the maximum area right there, 800 square feet. Notice that this is f of x is equal to y. So this is area as a function of width, A of W. So that corresponds to the Y, the output value, the Y value. All right. Does that make sense? Darn, trying to get in the frame right here. Okay, I think I was out of frame. Okay, so there's a problem where we maximize the area. So once again, I had the rectangular shape. So I drew the shape. Anytime you have a word problem involving a geometric shape, draw and label the shape. Okay, so I drew and labeled the shape. I wrote down what I'm looking for. So I'm looking for the formula, and I'm looking to maximize the area. Okay, so that keyword maximize means find the vertex value, the Y value at the vertex. So the shape is a rectangle. I wrote down my relationships for rectangle, perimeter, and area. And then I just plugged the p-value in there, and I was able to solve for L. I plugged that into A, and I got one equation and one unknown, which is a quadratic equation. So a parabola right here. A is a function of W is equal to negative 2W squared plus 80W. And the negative is what I want. So the negative means it's going to open downwards. And so the vertex is a maximum value of the function. And then over here, I found the W, meaning minus B over 2A right there. I was able to plug that back in then and evaluate the area of the garden. So I was able to, once I found W, plug that back in and find the maximum area of the garden. And then from that, I could find the length. Okay, now I know everything that I need to know for my garden. I've maximized the area using 80 feet of fence. So it's 20 on the two sides and the length is 40 feet. Okay. And notice 20 plus 20 plus 40 is 80. So it works out. So any question on that? That's what we call a maximization problem. All right. So don't let that word maximum or minimum weird you out. All it means is we're going to find the vertex value of that parabola. Put that back over there. Okay. So let me see what we got next. All right. So the last thing we're going to talk about in here, we sort of talked about it already, and that is the intercepts. Okay. So let's see. For right now, there's a maximum revenue problem in example 6. So I'm going to skip that for right now and go right to the X and Y axis intercepts, which is over on page 353. Just a second here. That's 71. Okay, easy enough. 73. Okay, cool. Those are good. All right. So let's go over to page 353, where we're going to talk about finding the intercept values, the X and Y intercepts. All right. Flip this over. Oh, dang it. Almost out of time. Rats. Okay, no sweat. We can do a little bit of introduction then to intercepts. So this is in terms of objectives. I don't have a number for this one, but it's over on page 353. Okay, so here's our coordinate system. Y. Here's our function running through that. Okay, so we have x-intercepts here and here. So I have two x-intercepts. And then right here, I have one y intersect. And write the y-intercept over on the other side. Hang on. One y-intercept. Now the x-intercepts are called the roots or the zeros. The roots or the zeros. That's what the x-axis intercepts are called. And unfortunately, we're out of time. But that gives us a little bit of introduction into what we're going to look at next time. Okay, so let's see. Just a minute. Yeah, and we're actually a little bit over time here. So that's all I have for tonight. So unfortunately, we're over at 6:25. So any questions? Quick questions? Okay, make sure you sign into the chat there so I can keep attendance for everybody. Again, if you have any questions, you can also ask me, send me an email.
Thank you, Professor. Have a good night.
Bye. Have a good night.
Okay, yeah, good night,
Thank you.
everybody.
Good night. Thank you, sir.
Sure, good night, Ken. Thank you.
Hey, Professor, can I just see what you wrote behind you? Just for a second.
Oh, behind my head? Yeah.
Yeah.
Good night. Thank you.
Okay, you're welcome.
Okay. Thank you, Professor.
Sure.
Professor, can I ask one question, please?
Yeah. Uh-huh.
My name's Anna. I'm the one that added kind of recently. I emailed you on Friday. I just
Right,
wanted
I
to double
remember.
check with you if you covered anything from 5.2 in last week's lectures or if those were 5.1.
No, everything we've covered so far has been in 5.1.
Okay, perfect.
So that schedule on the schedule on the syllabus is our ideal schedule. If I just went as fast as possible and covered everything. The problem is the author puts so much stuff in the different sections that it's impossible to stick to that schedule.
Yeah, no, I'm actually glad because it takes me a while to review a lot of this stuff. So I was glad that it was 5.1, so I had a little more time to catch up.
Okay, good.
Thank you so much.
All right, we'll see you next time, Anna. Thank you.
So Professor, are all our assignments and homeworks due in person when school reopens?
Yes, they're due when we go back into the classroom. So the assignments, I will send you the assignment tonight, and it's also on Canvas.
Canvas,
on
right?
our
Yeah,
Canvas
found it.
shell.
Yeah, and then the tests are in person as well, I'm assuming, correct?
I'm sorry, and say again?
The tests are in person as well, right?
Yes, all the
Okay.
tests are in the classroom.
Okay, perfect. Awesome.
Uh-huh.
Thank you so much. Have a great night.
You too. Thank you.
Professor,
Yeah.
for the assignments, does it actually have to be exactly how you did it in class, or?
No, there's more than one way to do everything. So as long as you have some sort of legitimate way to do it and show me the work, then that's good.
Oh, okay, so it doesn't have to be like half, what do you call that? The halves and the, like 1/2 over 5/3 squared, something like that. It doesn't have to be like that all the time.
Well, you need to know how to, in completing the square, you need to know how to find that number. And that's the
okay.
method for finding that number. It's 1/2 of the middle number squared.
Okay, okay, sir.
Okay.
Got it.
All right,
Sorry
good.
about that.
Okay, we'll see you next time.
Bye.
Bye-bye.
Thank you.